Hello. So in this particular video we are going to see the code to run the DC motor or to control the DC motor by using the microcontroller 8051. Now here first we will see what exactly we wish to do over here. So the objective of this particular code is to rotate the motor in a clockwise direction and then rotate that same motor in the anti-clockwise direction. Now to do this particular thing, there are some steps to be followed. So you cannot rotate the motor clockwise and immediately in the anti-clockwise direction. So what I need to do, the steps are given over here. The first step, that first you send the signal from the microcontroller to the DC motor through this particular L293D IC to start the motor in a clockwise direction. So that is the first signal seen by the microcontroller. Then obviously I need to keep that motor running in the clockwise direction for some time. So I need to provide the delay over there. So that is the step number 2. Fine. Then so this is the first step 1, step 2. And then in the next step, obviously I cannot immediately switch from clockwise to anti-clockwise direction. So first I have to stop the motor and then I have to send the anti-clockwise direction signal. So the third step, I'll go for the stop signal. I'll send the stop signal to the motor through the microcontroller. Obviously immediately I cannot start the anti-clockwise, so I have to stop for some time. So the motor will be stopped for some time using the delay, that is the fourth step. Now in the next half I will be sending the signal from the microcontroller to rotate the motor in anti-clockwise direction. So that is the next fifth step. Obviously I need to keep that particular motor to be run in the anti-clockwise direction for some time, and that's why I need to provide the delay over here. Obviously once the delay is over, I have to give the stop signal, otherwise what will happen, the motor will immediately go to the clockwise direction, which is not advisable over here. So we are supposed to stop the motor first, and hence we are sending the stop signal to the motor. Once the motor is stopping, again I have to keep that motor stop for some time, that is nothing but I have to provide the delay, and then again I have to repeat the code from the first step, that is sending the signal from the from the microcontroller to the motor to rotate in the anti-clockwise direction. So that is the first step I have to follow. Likewise the entire what you can say, the steps will be followed and the motor will be running clockwise for some time. It will be on a stop position for some time, then it will start rotating in the anti-clockwise direction for some time, and then it will stop for that anti-clockwise direction, it will stop for some time, and again it is rotating in the clockwise direction. So these are what the steps will be basically followed. Fine. Now we will see actually the program over here, or the code over here. Fine. So this is the main program over here. As you know, this is the method or the language to be used while writing down the program in the microcontroller. So the first step will be ASMORG 3000. It means what? I am starting my program or the code at the 3000 address. Okay, I am originating my code at the 3000 address. Now I just want to tell you that this particular code I'll be using in uh, decimal. I'll be using in decimal. So no need to write the H over here, uh, which was done in the case of blinking the LEDs. So I'll be using this particular code in a decimal. So I'm not writing H over here. Right? Then, as per the previous step, that first step will be rather the previous slide, the first step was to send a signal to the motor for starting motor in the clockwise direction. So this is the command, that move 90 comma hash 01, where 90 is nothing but what, the address of output pin, and the 01 is nothing but the value which I am sending to the that particular pin. Now this 01 is in the decimal. Okay, and why this 01 has come, that I'll explain first of all. See, we have 8 bits, that is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6 and 2 raised to 7. As I said that I am going to use two pins over here because I need to send the two signals. One is clockwise and another one is anti-clockwise. So I'll be using two pins. Let's say I'm using this pin and this pin. Okay, these are the two pins I'm using. So to send the clockwise direction, obviously I need to make this particular pin to be high. Okay, then only the signal will go to the first pin. That signal will be high, and the signal will be given to the motor. So I wish to make this particular first pin to be high. So I am writing 1 over here. Okay, we know that 1 is nothing but the high signal. So if this is the 1, then the rest pins will be obviously at the 0 0 0 0. Okay, now if you see, I'm just considering the last two digits because I am having the last two pins only. So if I observe, the last two digits will be a 0 1, and hence to rotate the motor in the clockwise direction I am using the 0 1 over here. This is the 0 1. Fine, that is how that 0 1 has come. Okay, then obviously I need to keep the motor to be run for some time, so I need to provide the delay. I am calling the subroutine program which is written at the address 3030 by using the lcall command. So this is the first delay I am using by using the lcall command. Then the next step, obviously now the motor is running in the clockwise direction, and now I wish to stop the motor. So to stop the motor, I am using the command move 90, #00. Now you know that move command, that you are just loading that particular register with the particular value. Now I am sending the 00 value to the output pin. So now if you see, again going back to this particular bits, 00 means what? Everywhere there will be the 0. There, this will be the 0, this will be the 0, 0 0 0. Everywhere there will be the 0. So there is no signal. It's a low signal. So when there is low signal, the motor obviously is going to get stopped over here. Then I need to keep the motor in a stop position for some time. So obviously I need to call the delay over here. So I am calling the delay by using the lcall command. Again, that I am using the same delay which I have written at 3030. Fine. So the first step is done. Now I want to rotate the motor in an anti-clockwise direction. Fine. So for this particular thing, for anti-clockwise direction, I am using the command move 90, #02, where this particular where from the 02 has come. Again you will go over here, that just write 2 raised to 7, 2 raised to 6. I am writing all the pins again, 4 3 2 1 0. Okay, now initially I made this particular first pin high. Okay, now I want to make the second pin high because I want to rotate the motor in the anti-clockwise direction. So I will be writing the 1 over here to make the second pin high, and obviously the rest all the pins will be having the signal 0 0 0 0. So considering the last two digits, I will be having 1 over here. So when I am writing 1 over here, what is the value of this? That is 2 raised to 1. That is nothing but the 2. That is nothing but the 2. Okay. So I will be using the 02 command over here. Similarly, when I am using high over here, the value was 2 raised to 0. The value was 1. Okay. And it was hence 0 1. Fine. And I was using the 0 1 over here. Similarly, I am making this particular pin second pin high. So the value of this, the answer of this 2 raised to 1 is 2. So I am using that in the decimal, as we have already seen the conversion of this particular binary to decimal. So this value will be the 02. That 02 will be I am using as the signal over here. Fine. Then I will be going for the lcall command because I want to keep the motor to run in anti-clockwise direction for some time. So obviously I will go for the delay, which is at the 3030. Then I will stop the motor, again the same command which we have used over here. Okay, 00 signal I will be sending, and then I need to keep the motor at the stop position for some time. So I need to call the delay over here again. So I'm using the lcall 3030, and lastly the motor has stopped. Now the motor again I have to start from the clockwise direction. So I'm using the LJMP command to jump over here to the address nothing but the 3000, which is my starting address. So which will keep the program in loop, over here. So from here the motor will be jumped to this ASM to the 3000 address, and the program again will start executing over here. So this is the main program. Now next we will have the delay program, that is nothing but the subroutine. So in the subroutine, already we know subroutine program, already we have done that. So the subroutine program is nothing but the again I am starting that particular subroutine program at 3030 as I have written in the main program. Okay, so first command will be, I will be loading. I am using 3 registers over here, R1, R2, R3. You can go with the 2 registers as well. So as you reduce the register, obviously the delay time will get reduced, and vice versa. So I'm loading the first register R1, okay, with the 0FF. Now you know that the meaning of 0FF. 0FF stands for everywhere in all the 2 raised to 7 to 2 raised to 0, everywhere there will be the 1. That is nothing but the FF. Okay, so this is the high signal I am sending to the R1 register. So I am loading the register R1 with the high value. Again I am going for the next register R2 with the high value. Again I am using one more register R3, which is again with the high value. So I am using 3 registers, and I have loaded all these 3 registers. Now I will just go on decreasing the all 3 registers one by one. So we know that initially when I want to decrease this particular register, the latest register will be get decreased, and it will be decreased to the address where I am writing down the code. So suppose I am having the address over here 3036. So at 3036 only I will be decreasing this particular thing. So it will be djnz r3 3036. Now the djnz is the command used for the decrement. So that already we have studied. So 3036 address I am decreasing first R3, then I decrease the R2, then I decrease the R1. Okay. So basically what is delay? The delay is nothing but it is the time required for the registers to load and get unload. Okay. So as you go on increasing the register, the time required to load and unload this all the registers will be go on increasing, and vice versa. Fine. Now the last command I am using is that is the RET. So basically the RET is nothing but it's a return command that it will tell the subroutine program, yes, your work is over, now you go back to the main program, and for that purpose the RET will be used. Fine. So this is the code for controlling the DC motor or driving the DC motor in clockwise direction and anti-clockwise direction by using the delay. Okay, thank you.